Hello friends, welcome. This is Sarveshwar and today we'll discuss a very interesting topic in econometrics. Friends, when we use simple regression against penal regression. So in the penal regression, we are having a benefit. We are just combining a lot of cross sections with the time series to get some good results, more efficiency because of more observations. But one thing that requires a lot of attention in data, which effect you need to use actually, fixed effect or random effect. That is a great puzzle, friends, in research for econometricians. How to do that? Uh, it's very simple. Though we have so many tools, softwares that makes it very easier, but for intuitive understanding, what is difference between fixed effect and random effect? We need to know that. So today I would try to just resolve this dilemma or puzzle uh, just to get the intuition behind fixed effect and random effect. Okay, friends. So first of all, friends, we need to know what kind of models we run when we assume that we are using fixed effect or random effect. So first we'll discuss fixed effect model. This is our fixed effect model regression, friends. Here we are regressing our yth variables for all firms on intercept that is constant across firms uh, plus some intercept dummy variables for all the firms n minus firms. Here I put n minus 1 for the firms. Then we are using some coefficient for x2 variable, then coefficient for x3 variable, plus random error term for each term in our model. So here, friends, what we are doing actually, we are assuming for the intercept. We come to the intercept part, friends. Here, what we are saying, for each and every firm, there is some fixed effect beta 1 plus some heterogeneity across firms. That is, we are capturing by dummy variable for each firm. This is called fixed effect model. We are saying the firm could be heterogeneous from other firms. For that purpose, we are giving a dummy and capturing that heterogeneous effect. That is why how we are controlling for heterogeneity across firms. This is our fixed effect model. But when we come to random effect model, the simple equations we are saying here, the the first equation we are seeing here, friends, this is our equation that is very same as the first firm, but instead of writing dummy, I have using beta 1 I, means beta 1 is changing for each firm, means the beta is heterogeneous across firms, but I am not taking dummy here, just I'm simply saying a beta is changing. It could be heterogeneous plus all other the same equation as the fixed effect model. But here what we are assuming, friends, each the model of firms, suppose we are having six firms, so these firms are coming from a larger population. So if we assume it, the sample we are getting like six firms, they are coming from a larger population. This is assumption. In that case, what we are saying, the beta we are getting, actually it is some fixed plus some random error part with each firm. So I'm just when divided in two parts, beta 1 I is equal to some constant beta across firms plus some heterogeneous part error I, and we are saying this error part, error for individual epsilon ei epsilon I, it is random for each firm. So here we are saying we are having two errors. First is in first model mu it, second is epsilon I for each firm. So in this way we are having two errors. One is individual specific and one is the model specific for each term in the model. This way, uh, so when we run regression, friends, we are having two errors and we put them together, assuming they are both of them are random. We are getting some omega it error term in last equation, where we are regressing in this way. Omega it is a combination of both terms. So here, friends, for understanding purpose, we are having two errors. First of all, first individual specific, second is as per the model, and third is composite that combines individual plus model. So in this way, but for comparison and understanding purpose, I will be taking two. First individual specific, that is epsilon I, plus omega it in the model, the last equation I have highlighted, that is composite error term, and we are assuming that all the errors are random. This is our random effect model, but this is part I have explained. But what model we need to use actually? Okay friends, so when suppose we assume that this individual error part is not correlated with these regressors x and y. I am saying the individual specific error, those are not observable friends. It is not observable. So some hit and error methods we are using. So but for simply these individual specific errors and the regressors we are having in a model, the axis, if they are not correlated, we are saying there is no correlation between them, then we can let this error go with mu it, and we can say we can use random effect model, assuming there is no correlation between regressors and individual unobservable error component. But if we assume that there is a correlation between these regressors and individual error components, then we have to use fixed effect model. Friends, so our which model we need to use, fixed effect or random effect, lies in our assumption whether there is a correlation between this unobservable error component, individual error component, and regressors. If correlation exists, use fixed effect model. If there is no correlation, use random effect model. And for the summary purpose, the assumption of the random effect model is that the population, the n sample we are, the sample we are getting here has been drawn from a larger population, and unobserved errors for individual intercept are part of composite errors. This is the main assumption for our random effect model, and there is no correlation between firm specific error component and regressor axis. In this situation, we are saying random effect model is an appropriate model. Otherwise, fixed effect model. For layman terms, like how to do that, how to do fixed effect model, simply if we give dummy, it's fixed effect. If we don't give dummy, and we assume that the heterogeneity is part of composite error, then we can say it's a random effect model. So this is the simplest way, friends, we can explain fixed effect and random effect. I have tried my level best. If you have any problem, friends, please write. Thanks for watching.